All right, then problem number 2 then. Problem number 2 asks you, let's see, where did I write that? Where is that? Complete the equation for a reaction between solid aluminum. Well, solid aluminum is Al with the symbol S, S meaning the solid. For a reaction between solid aluminum and aqueous chromium chloride. Well, let's see, chromium, it says chromium 2 chloride in the problem. Chromium 2, the Roman numeral 2 in chromium 2 means there's a charge of +2 on this chromium ion. So chromium 2 is chromium with a 2+ charge. Chloride is Cl with a 1 negative charge. And you look up that negative charge on the periodic table with oxidation numbers. Chloride, the IDE ending, means it's a chlorine that has a negative charge. And the only negative charge for chlorine is that 1 negative. And so when you put these together, you can see that you need 2 chlorines to balance with a negative charge each, to balance out the 2+ here. And so the formula then becomes CrCl subscript 2. So there's our formula. So it's in the equation then, CrCl sub 2, and the question or the prompt tells you it's aqueous. So you know it's dissolved in water, we can put aqueous here. You don't have to even look it up. It says that there is an excess of chromium 2 chloride and we're going to be producing aluminum. I'm sorry. We're going to be producing chromium metal. So we know one of the products over here is chromium metal. Well, chromium is Cr. A metal is always a solid unless it's mercury. So we need to figure out what the other chemical is that might be over here to take care of all these other atoms. What classification of reaction do you think this is going to be? Single displacement. Okay, recognizing what kind of equation it is, what classification of equation it is, helps you predict the products. And in single displacement, the element that's by itself has to displace the part of this formula that it's like. Well, aluminum is like chromium in that both are metals. Okay, so aluminum is going to displace the chromium, and so we're going to have an aluminum and chlorine combination over here. What I haven't done is to balance this formula yet. Now, remember, subscripts only travel when they're part of a polyatomic ion. This is not part of a polyatomic ion. Chlorine is just one chlorine. All right? Chloride is just one chlorine with a negative charge. So this 2 didn't travel. We have to figure out what charge to put on this. So you go to your periodic table with that oxidation numbers, and you see that aluminum has a 3+ charge. We're putting that together with the chlorine with a 1 negative charge. I hope that you can see how many chlorines you need. 3. AlCl sub 3. All right. So now what physical state do we assign to this thing? Well, since we're in a water environment, and we know that because at least one of the chemicals is aqueous. Yes. Do you?
I do.
Okay. Will you have your pass?
Yeah.
Let me just make a note on there right quick. Okay. There you go. Alright, so if you go through the solubility rules, we can find out whether this is going to be a solid or a gas. I mean, aqueous compound. We know it. I mean, you don't recognize it as a gas. I wouldn't give you one that you didn't know about. So chlorides, it says, all of them are soluble. If there's water around, they'll be aqueous. The exceptions are silver, lead, and mercury. I mean, obviously, this is not one of those, so this must be aqueous. Now we need to balance the equation. Okay, you can't come up with a molar ratio to answer this question without the balanced equation. The question, or the prompt says, determine the moles of chromium metal produced from 7 moles of aluminum when there's an excess of chromium 2 chloride. Without a balanced equation, you can't do this. You can't get from one species to another without a molar ratio, and you can't have a molar ratio without a balanced equation. So, for a balanced equation, we're going to use an atom inventory. Count all the elements on the left, or the atoms on the left. You got 1 aluminum, 1 chromium, and 2 chlorines. And on the right, we have 1 aluminum, 1 chromium, and 3 chlorines. The way that we're going to get the chlorines to be the same on both sides, and we're trying to get all the elements to be the same, is I have to put a coefficient of 3 in front of the species that contains chlorine here, and a coefficient of 2 in front of the species that contains chlorine here. Okay, if you would sign in and put this in your personal file. Hmm? Can you fill it up? Yeah. Okay. Let's see. We're going to have to count now the number of chromiums and chlorines on this side because I changed the coefficient. And you need to count the number of aluminums and chlorines on this side because I changed that coefficient. I now have 3 chromiums and 6 chlorines over here. I have 2 aluminums and 6 chlorines over here. To get the aluminums to be the same now, I've got to put a coefficient of 2 in front of the aluminum species. So that will give us 2 aluminums. And to get the chromiums balanced, I've got to put a 3 in front of this, and that'll give us the balance we need for the number of chromiums. So there's the balanced equation. Now we're ready to actually solve the problem. We've done all the preparation we need to do to solve the problem. Is that our next one? So everybody has a copy of the double replacement lab and the District 6 focus? Yep. Okay. All right. So our starting amount in this problem is 7 moles of aluminum. Starting amounts always go over a number 1. And then to go from the moles of one species to the moles of another, and that's what the question is asking you to do, or the prompt is asking you to do. We're trying to go from solid aluminum to, let's see, chromium metal. We're going to use the coefficients in the balanced equation. So we have 2 moles of aluminum in the equation. I want to put that 2 moles of aluminum down here because that matches the units and species I have in the starting amount. And I'm going to put the moles of chromium on the top because that's what I'm trying to find. So now I cancel out this, cancel out this. Did I ask you guys to exchange your papers a while ago? Okay, I just want to make sure. So Corey, if you got your homework, you need to give it to me right now. I'm ready to do the math. And let's see, that answer is going to be 10.5 moles of chromium. All right. Okay, so let's go through and figure out how many points to assign for this. And there are a lot of them. Since you had to figure out the equation for yourself, I'm giving you points for the atom symbols and the physical states along with the coefficients. So there's 1, 2, 3 there. 1, 2, 3 points. I'm sorry, not that. This 3 points there. 1, 2, 3 there, and 1, 2, 3 there. Okay. The 2 on what? No, I just gave you a point for the whole formula being right. Okay. All right, so the atom inventory, writing down all the atomic symbols is worth a point. Writing down the initial count properly, that is counting the number of atoms before you do any balancing properties, a point. Canceling out, drawing a line through the thing you're changing, that's worth a point. And the final number is worth a point. Okay? Okay. Then for the actual calculation here, 7 moles aluminum. Each of those get a point. Plus canceling those out, get a point. I'm giving you a point for putting in a time sign. A lot of students tend to leave those out, and you need to have those in there so you can keep up with what you're doing. 3 moles of chromium is worth, each of those is worth a point. 2 moles of aluminum is worth a point, plus canceling out moles and aluminum is worth a point. The equal sign, that's important. Okay? And then 10.5 and moles and chromium is worth a point. Now I've counted that right. That means that this part is worth 51 points. The other was 23. So the total for the entire homework is 74 points. That makes sense?